Good afternoon, children and parents. Today I'm going to cover the circle theorem and angles. This is a popular topic in both the Cambridge exams and the GCSE exams, whether it is a QA or Edexcel. Okay, so let's start. Why don't we start with understanding some parts of a circle? All right, why don't we start like this? Let me draw a circle and you will understand what I mean. Look, I'm not very good at drawing a circle. Okay, let's see, this is a circle. Right, like in any circle, the circle has got something at the center here, and that is called the center. Very simple. It's got a center. Now, if I draw a line from the center to anywhere on the circle, anywhere, that line here, we all know, is called what? The radius. Okay? That blue part here that you see, the circle itself, that one is called the circumference. Now, if I take a line anywhere on the circle and I draw a line that passes through the center and I extend it here to the other side of the circle, yes, that is called the diameter of the circle. I don't like it. The color is not very good. That's called the diameter. Yeah. And the diameter is always equal to 2 times the radius. It's twice, right? So this is a radius and this is also a radius. So we have 2 radius here. So the diameter is always equal to twice the radius. Okay, that's what we need to understand a bit about circles. All right, now I move on. I'm not going to draw another circle because I'm not very good at drawing circles. Up. Now, if I draw a line here on the circle that does not pass through the center, see the center, you see the line? The line doesn't pass through the center. That line here is called a chord. Okay? So a chord is always smaller than the diameter. Actually, the diameter is a chord in itself, to be honest, right? But because it's the maximum length you can obtain for a chord, we give it a special name. We call it the diameter. Okay, so that's called a chord. Now, this large area that you see here See, this side is very large, right? This large part. That called a major segment. Okay, it's large, as you can see from the drawing. It's the bigger part, and the smaller one here, smaller section here, is called the minor segment. Okay, you understand that? Good. Now I will highlight. See this part of the circle here? That part of the circle here along the circumference, that one we call it a pen. That one we call this the major arc. It's an arc, right? That's called the major arc because it's part of the major segment. As simple as that. And this smaller part here, this arc here, the smaller one, this is called the minor arc. It is smaller, right? Minor. So here we have major, the bigger arc, and the smaller arc is called the minor arc. So you have to learn these technical words, all right? So when somebody says the major arc of the circle, straight away you know, oh, that's the bigger part of the circle, and you know there's a chord that's separating the two. Yeah, I mean, dividing the circle into two parts, where you have a larger part that you call the major segment and a smaller part that you call the minor segment. Okay, so straight away when you hear about major arc, you know, visually you can see it. Okay, you can understand it better. Right, and again, my eraser is right. Okay, let's go. All right, next, if I start from the center here and I draw two lines here, no? Instead of having a chord, now I have two radius here. Okay, that large part here, what's the name we give to it? That large part here, we call it the major sector. And this one here, you would have already guessed, this is called the minor sector because it is the smaller part. Now, why do we call this sector and not segment? We call it a sector because it starts from the center here and we have two radius here. The sector. Whereas if it was like a chord, I draw a chord here, then that part will be called a segment. Okay? Don't get confused between sector and segment. So when I'm talking about sector, straight away you can see, the circle is divided through the center this time. And when I say segment, the circle is divided into two parts by a straight line, a chord. Alright, so you got that? Fine. Now, any line is any straight line that passes, that touches a circle here, a straight line that touches the circle, like here, it's touch it here. That line is called a tangent. Okay, this line is called a tangent. Because why is called a tangent? It does not pass across the circle. It just passes and touches one point on the circle. That point. The line passes, it touches the circle only at one point. So that line is called a tangent. Look, if I draw this line, that line touches, there are 2 points here. It touches the circle at 2 points. Whereas here, it's 1 point. So where the line touches only 1 point of a circle, that line is called a tangent. And this one, obviously, is called a chord. Alright? You've got that? Fine. That's all I wanted you to know about the circles at the moment. Just understand what is a sector, what is a tangent, what is a circumference, what is diameter, what is segment, what is a chord, etc. Alright? Okay, so let's move on. Now let's learn a few things about circles. It's quite interesting, circles, actually, when you think about it. Alright? So let's move on. Let's consider this circle here. Okay, I'm not very good at drawing, I say. Okay. If this is the center, and I draw the diameter here, this is the diameter. Okay. From these 2 points, from the diameter, if I choose any point on the circle and I join it to the 2 ends of the diameter, okay, let's call this AB, any points. So if I take any point on the circle and I join it to the 2 ends of the diameter, these 2 ends are A and B, right? The angle at the circumference will always be 90 degrees. Okay, you got that? So if I take this point here, for example, okay, this point here, and I join it to the 2 ends of the diameter, this will be 90. This will be 90. And if I take this point here and I join it to the two ends of the diameter, this will be 90 degrees as well. It will always be 90 degrees. Do you want to know the proof? Do you want to know how to prove it to someone, to your teacher? All right, shall we try and prove this? Okay, let's do that then. Okay, let's prove that the angle at the circumference with the diameter is 90 degrees. Okay, how do we prove that? All right. Let us, we said from this point here, where it touches the circumference. Let's start with this point. Let us join it to the center. What can you say about this line here, and this line here? Let me label it so we can understand. A, B, C, and this is O. I think AO is equal to OB, which is the radius, which is also equal to OC, right? Do you agree with me? Yes? Okay. So if they are the same, so this length is the same. So what have we got here? We got two isosceles triangle, right? We got AOC and COB. We got two isosceles triangle. Okay, let us call this angle X. Okay, therefore this angle and this angle would be what? 180 degrees minus X divided by 2. Right, you agree with me? I mean, from the properties of the sum of interior angles in a triangle, we know that it has to be 180. So therefore, if this angle here is X degrees, right? So this one here, this angle here would be 180 minus X divided by 2, because these two angles have to be the same. Why they have to be the same? Because it is an isosceles triangle. So angle COB has to be equal to angle CBO. Why? Because it is an isosceles triangle. Very simply, that's the reason. Now, let's move on now. If this is X, this angle will be what? 180 minus X. You agree with me? Because this is a straight line. So, and also, like I said, triangle AOC is an isosceles triangle. Therefore, these two angles here, they have to be the same. Right? So, what is this angle here? It's a bit complicated in terms of algebra, right? Some of you might find it easy, but some of you might find it difficult. So, let's call this angle Y. So, Y will be what? 180 minus this part here, 180 minus X. The the whole lot I divide by 2. It looks a bit weird, right? So actually this will confuse you. Let me write it in another form. Y will be 180 minus, upper bracket here, 180 minus x, right? The whole lot I divide by 2. Okay? When you do that, you open the brackets. Y will be what? Y will be this bracket here, 180 minus 180 plus x divide by 2. Then, as you can see, this becomes 0. Y is equal to x divided by 2. You agree? Now, the angle at circumference will be y, which we found already, will be y plus what? Plus this. Plus this angle, right? Plus 180 minus x divided by 2. What is y? Y is equal to x divided by 2, right? Plus 180 minus x divided by 2. That becomes x plus 180 minus x, the whole lot, divided by 2. This is equal to 180 divided by 2. Why? Because the x that cancel, and 180 divided by 2 is equal to what? 90 degrees. Here's the proof. This is how you prove that the angle from the diameter to any point on the circle has to be 90. It is always 90. Alright? I hope you understand that. Just, if you don't, just go back again and look at it, think about it, see where I get my figures, and you will most certainly understand why the angle has to be 90. Okay, you will understand. I'm sure you will. You are very smart. I know that. Okay, now let's move on. Let me draw another circle to explain the concept. What a perfect circle that guys, I'm not good at drawing on a glass tablet. Okay, it's not that easy. On paper I can do it, of course. Now, you remember we were talking about sector. So if I have to draw a circle that will show me sectors, I will have to draw a line from the center to any part on the circle. Then I have to draw another line from the center to any part on the circle. So here we got a circle divided into sector. Right. If I take a line from point A here I draw a chord, for example, and I join it to B here. Let me call this C. What we will find that if this angle is X at the circumference, the circle at the center will be 2x. This is a theory. This is the rule. The angle in this situation here, the angle at circumference is half of angle at center, or you can say angle at center is twice angle at circumference. If I draw another this, you will still find that this angle, okay, will be X as well. Right? Now, do you want to know how to prove this, or are you getting tired already? Do you want to prove this? You know what? Let me prove it to you. Okay, let me prove it to you. I think that's enough. Right. Okay, I said, let me draw a line here from C to, this is point O, which is the center. We know that AO is equal to OB is equal to OC, right? Which is equal to the radius. Again, we have two isosceles triangles. Okay, let me call this Y and oops, and let me call this X. Right, what we're trying to find we're trying to find these angles here, this one. This angle and this angle will be the same. Why? Because it is an isosceles triangle. Likewise, this angle here and this angle here will be the same. Same angle. And here also, same angles. Right? So, what is this angle here? This one. This one will be 180 minus X divided by 2. Correct? These two angles here. Similarly here, these two angles here will be 180 minus Y divided by 2. Okay? You agree with me? Very good. So, this angle is what? I'll call it angle OCD. B, and this will be angle OCA. Angle OCA. All right. Sometimes we write angle like this, huh? Don't forget. Remember this. We write angles like this sometimes, called in this way as well. All right. So let's calculate angle. Angle ACB will be equal to what? Will be equal to angle OCB plus angle O. It's not OCA, guys. Alright, it's OCA, yes. OCA. And what is this angle? It's 180 minus x divided by 2 plus 180 minus y divided by 2. Okay. If we simplify that, what will we get? We will get 180 minus x plus 180 minus y, the whole lot, divided by 2, which is equal to 360 minus x minus y divided by 2. Right? This is angle ACB, right? And this angle is at circumference. Now, what is the angle at the center? Angle at center is what? Is angle AOB. Not any other business, all right? AOB is AOB, right? And what is AOB? What is this angle? Very simple. It's 360 minus x minus y. Yes, I call this equation 1 and I call this equation 2. Angle AOB and then angle ACB. What do we notice about this? AOB is 360 minus x minus y, and ACB is equal to 360 minus x minus y divided by 2. Therefore, angle AOB is equal to 2 times angle ACB. Right? No, I don't want to confuse you. Let me put it that way. Yes, here you go, guys. AOB is angle at center, and ACB is angle at circumference. Here we go. I've just proven to you that the angle at the circumference, at the center is always twice the angle at the circumference. Cool. Let's move on to the next now. So, oh, that's not nice. Okay. Center here. If I draw a chord here, let's call it AB, and I draw I got this point, let's say I call this point A, B, C, D, right? Let's consider this, okay? Look at this drawing here, and this is the center. You know what? You will find out if you have a chord AB, and then you just take any point on the circumference and you join this point AB anywhere, all right, even here. If I do that here, what you will find is that this angle here, this angle here, and this angle here, right? If that is x, this will be x, this will be x. Always. Okay? That's what you will find out. If you take a compass, you draw a circle, you draw a chord, and then you do as many triangles on the circumference from the chord, right? You will find that the angle at the circumference, at those points there, all 3 points there, are the same. It will always be the same. All right? So, in brief, what we can say, the angle formed at the circumference created by a chord, in this case is AB, will be the same anywhere in that part of the circumference. It will be the same. Now, can we prove it? You know, it's good to know how to prove things, because when you manage to prove something, that means you will understand it better, and when you understand something, you will never forget. Okay, let's go ahead and let's go and try and prove this, shall we? Okay, the proof. How are we going to prove that? It's not that difficult. If I join these 2 points to the center here, okay, and let me call this y different. Okay, so we learned before that the angle at the center has to be twice the angle at the circumference. If this is x, then that will be 2x. And if this y, it will be 2y. But this angle is the same for both of these angles, right? So 2x must be equal to 2y. Do you agree with me? Yes? So if 2x, where I get the 2x is, this angle is x, and we know from our previous lesson, if this angle is x, then the angle at the center has to be twice. Similarly, if this angle is y, then this angle will be 2y. But this angle here hasn't changed. It's the same angle. The same. If you measure this angle, it will be the same. You will get the same result. Therefore, 2x has to be equal to 2y. If 2x is equal to 2y, then x is equal to y. This angle has to be equal to this one. This is straightforward. Has to be equal. So regardless where the point is, you draw anything here, you draw here, you draw here, the angle will always be the same. It will be x everywhere, x. Okay, I change this to x now. So it will be x degrees everywhere. That's a very simple, simplest proof. Alright, let's move on to the next. Oh, by the way, we call this part of the theory the angles in same segment. Right, remember a chord, this is the major segment and this is the minor segment, and here this is called the sector, so I will call this here angles in sectors. Right, so let's move on to the next topic. Oh my god, what a punishment to draw circles with a stylus pen. Here we go. I think that's a better circle than the ones before. Again, this is the center, right? If we have a quadrilateral drawn inside the circle, okay, let's call this A, B, C, D, quadrilateral inside the circle. If I call this angle and this angle are opposite angle, right? You can see this. Opposite angle. Similarly, this one and this one opposite angle. If I call this angle A, angle B, angle C, and angle D, A plus C is equal to 180, and B plus D is equal to 180. This is what you will find, right? So the rule is the sum of opposite angles in a cyclic quadrilateral is always 180 degrees. Okay, this is, if you do this using a compass and you draw it with a ruler and you take a protractor and you measure it, you will find that the sum of these opposite angles has to be 180, right? Now, can we prove it? Okay, let's go and prove it. Right, let's say this angle is D, and no, I don't want to use D. Let's call it X. And let's call this angle here Y. So we're doing the proof here, okay? So we know, I just told you that X plus Y will be equal to 180 degrees. Okay? So, how to prove that is simple. If I start here and I go to my center, I know that the angle at the center is twice the angle at the circumference. Therefore, this angle will be 2y. Similarly, this angle here will be 2x. Alright, it looks a bit funny on my drawing because this is not a perfect kind of circle. So, from our previous lesson, angle at center is equal to 2 times angle at circumference. Right? From that we know that if that is x, that will be 2x. If this is y, this one will be 2y. Now, 2x plus 2y is equal to what? This whole thing here. Did I not tell you earlier on in my very first lesson that a complete turn, this is a complete turn, this is 360 degrees. So if I simplify this here, we will have 2 brackets x plus y is equal to 360. Therefore, x plus y is equal to 360 divided by 2, which is 180 degrees. Here is my proof that I have explained using algebra. Right? Very good. My God, 47 minutes. Oof. I've got 2 more things to explain to you on circles, alright? Just be patient with me. Right. If I have a circle here, this is my center. Go. If I draw, this is going to be difficult for me now. If I draw a tangent here, and I draw a tangent here, right? What we will find, we will find 2 things here. Okay, this is tangents. What we will find is that that point where it touches the circle, this will be the same here, will be the same length. Also, what we will find is from the center, and I join that tangent point here, this angle will be 90 degrees. All right. So, so what we can say is tangents to a circle that meet at a point, I call this point C here, will have equal length, and the angle with between, is it between the point, oh nope, and the angle it makes with the center of the circle is 90 degrees. All right. Good. Now I want to prove this, what I just explained. To do this, let me do a line here in the middle here. We know this is R, the radius, and let me call this length here X, right? So what is this length? What is this length? Well, using my Pythagoras theorem, that was my very first lesson if I remember well, we know that, let's say, this will be equal to x squared minus r squared, the root. Yes? And here as well, for here, this, let's say I call it question mark 1. Question mark 1 will also be the square root of x square minus the radius to the square, because it's the same, huh? We got the same radius and this line is common between these two triangles. Why are we using Pythagoras theorem? Because it's got a 90-degree angle here. As simple as that. These two are same. Therefore, length, this first length will be equal to the second one here. Right? If you want, I will remove these. Maybe you'll get confused. I call it L1 and I call this one, oops, my line is gone. Oh, and I call this one L2. So this is L1, this is L2, they are the same. L1 is equal to L2. The tangents, where these two tangents meet, they will have the same length here. Alright, now my last bit. This bit is, that's the last part. This one is called the alternate segment theorem. Right, oh my goodness. Hopefully I do something kind of perfect. Alright, consider this circle, okay? I draw a tangent here. And from this point, I just draw two chords. This is chord 1 and this is chord 2. Okay, and I join this here. What you will notice if you do that again, using a compass, right, you will find that this angle here and this angle here will be the same. I will label it for you so you can understand better. So if I call this A, B, C, and then a point here D, angle ACB will be equal to angle BAD. Alright? Similarly, this angle here will be the same as this angle here. Now, I'll show you a trick. Look at this angle here, right? These are opposite here. Going down direction, these are opposite. Okay, with the tangent. Opposite with tangent. Similarly, this angle here is opposite. So where the angle is opposite, the angles on the tangent and the angle in the triangle here, and they are opposite, they will be the same angle. So angle CBA, no, sorry, I missed a point here. Let me call this E. Angle EAC will be the same as angle CBA. All right. This is the angle. This is the rule. This is how it should be. This is what you got to remember. All right. It's 56 minutes. Let's see if I have 4 minutes. I'll try and prove this. Okay. I know I've been going very slow because I want you to understand it. Okay. Let's see. Okay. Let's prove this. Huh? Let me divide the circle into two, a diameter here, and this is my center O. All right. And let me draw a triangle here from the diameters, and let me draw a tangent here. All right, from our first lesson, we know this is 90 degrees, correct? And we also know this is 90 degrees. If I call this angle here X, this angle will be 90 minus X. Correct? You agree with me? Because the sum of the interior angles in a triangle is 180 degrees, right? Fine. Let me call this line, this chord here, AB. If I draw another triangle here, all right? Right. Before I do that, let me erase that. I did not finish one thing. I forgot. So let me find a different color. Yes. Okay. So this is X degrees here, and this is 90 minus X. And we know this angle here, the whole bit here is 90 degrees. Therefore, this angle here, this angle here, that will be our 90 degree, right? Minus this bit here, minus 90 degrees, minus X. Do you agree with me? If this triangle is, we got a 90 degree here, we got another 90 degree here, right? And this is X, this small angle here is 90 minus X. If this is 90 minus X, and the whole lot here is 90 degrees, therefore that bit here we're talking about, that is 90 degrees minus 90 degrees minus X. So 90 minus 90 minus X. So yes, that would be what? That would be x here. This angle here would be x. It's actually, you see, I missed something here. It will be x because I did not put it in bracket. That's why I was having a negative x. So 90, open bracket, 90 minus x, that becomes a plus. Alright, so I write it here, 90 minus 90 plus x. So if this angle is x, so this angle is x, right? This is equal to x. And here we go, we got x here as well. Right? We've got x. And applying the knowledge, applying what we learned from the previous lessons, if I draw this here, a circle here, a triangle here, given that we have the same code here, nothing has changed. This angle here will be x as well, right? This is what we learn. Look, this angle here, right? And this is what we have, x here, right? X, they're the same. So that's our proof. Okay, I forgot to put the degrees here. Alright, so you see, in this kind of situation, what we call this topic, alternate segment theorem. This is how we prove the angles are the same here. Look, go back to our lesson. Of course, where it meets the tangent. Yeah. Did you understand that bit? I hope you have understood. Right? If you haven't understood, just let me know. I will try and explain it again, much slower. Alright? Okay, thank you guys. I'm tired. I've been talking for an hour and 2 minutes without having a drink. So I'm gonna go and have a drink now. Goodbye for now. Cheers. Bye-bye.